Hey guys, welcome back to my YouTube channel. In this video, I will explain you about SPI protocol in detail. This is all that you need to know for a job interview asking SPI questions. So let's get started. First of all, few key points related to SPI. First of all, what it stands for? It stands for Serial Peripheral Interface, that is SPI. And it is a synchronous serial communication interface used for short distance. By saying short distance, we mean to say chip to chip communication on a PCB. It uses separate clock line and data line. It has a select line to choose that which device we want to connect to. We can see a diagram in which one device is the controller and the other one is peripheral. The controller can be seen as a master and the peripheral as slave. So this is master to slave communication. There are four pins. This is the simplest communication. Simplest means one-to-one communication. More number of devices can be added and this connection can be further improvised. The SPI sends data in two modes, that is LSB first and MSB first. LSB first means least significant bit first. If there is a data of 8 bit, then the least significant bit will be sent first. That will be the mode 1. And the second one, MSB first, that means the most significant bit will be sent first. Now let's see some more key points. So SPI has a lot of overhead. By saying overhead, we mean non-data bits. The overhead is required to maintain the consistency in the communication, but they are of no use with respect to its importance in data meaning or significance. They are just required for the communication itself. So they are kind of a burden. So it has a lot of overhead. And what is that overhead? Start and stop bit with every byte of data being sent. Major advantage is the simplicity of receiver device. The receiving device in SPI communication can be as simple as a shift register. In a system of SPI connected devices, only one device generates the clock and the device that generates the clock is called controller, that is master, and the other devices are called peripheral, that is slave. Master and slave concept are obsolete now. The master is now called controller and the slave is called peripheral. Out of the controller and peripheral, the controller will generate the clock and it will instruct all the peripherals that what will be the timing of the communication and other rules when the data will be sampled and when to be idle. That we will see a little later in this video. In an SPI environment, there will be one controller and can be multiple peripherals. The SPI is full duplex. Now let's see what happens when we want to add more number of devices in an SPI environment. The select line, that is chip select CS pin, will be used and it is active low. By saying active low, we mean that when the chip select pin is 0, then the device is selected. Now let's see that in detail. Using the chip select line, there are two ways of connecting multiple peripherals to an SPI bus, and these two ways have their own advantages and disadvantages. So let's see them one by one. First one is using separate chip select line for each peripheral. In this way, the number of chip select lines will be higher and that will be equal to the number of peripherals connected. For example, in a system, if there is one controller and five peripherals, then the total number of chip select lines required would be 5. So how many total pins will be there? 5 chip select lines, 1 clock and 2 data pins. Total 8 pins will be required. Now let's see the second method, by daisy chaining all the peripherals. By daisy chaining, we get rid of the large number of chip select lines, but here comes the disadvantage. Only one chip select line is required for multiple peripherals and all those peripherals are activated and deactivated simultaneously. Because when we send a data, let's suppose 0, then that 0 is passed to all the peripherals because they are daisy chained with each other. So how do we handle that? We send a series of bits through the chip select line that are pushed from one peripheral to another in the daisy chain to reach the required bit to the preferred peripheral. Now let's see few more key points related to that. SPI can transfer data up to 60 Mbps over short distances. SPI has no acknowledgement. The receiver device does not send any acknowledgement to the sender device that yes, I have received the data. So it can't guarantee the data reception. The SPI does not have any form of error checking just like parity bit in UART communication, and the biggest drawback of SPI is large number of pin requirement. Now, the four modes of SPI. SPI works in four modes, and those four modes are mode 0, mode 1, mode 2, mode 3. And how these modes are divided? This is divided based on the value of clock polarity and clock phase. This particular combination should look like a truth table to you. You can see 0001, 1011. So based on the values of clock polarity and clock phase, the SPI mode is decided. Now let's understand them one by one. By saying clock polarity equal to 0, that is here, we mean that the clock is 0 when idle and 1 for a pulse. This is a standard. And similarly, when clock polarity is 1, the condition is reversed. The clock is 1 when idle and 0 for a pulse. Similarly, for clock phase, that is here. When we say clock phase equal to 0, that means the data will be sampled on the leading edge of the clock. That is the starting of the clock. And when phase equal to 1, that means the data will be sampled on the trailing edge. That is when the clock is transitioning to the end. Okay, so that was an overview of SPI in detail. I hope you have understood them very well. If you have any doubt, you can ask me in the comment section. And that's it for this video, guys. Thank you very much for watching this video. I wish you all the very best for your job interviews.